In this section, we're going to talk about object-oriented programming, which is an extension of the things that we've been doing. In order to understand this, we have to kind of understand the concept of an object. An object is a structure that can hold its own values or data types, and also have a series of functions around them. Using this this paradigm of programming is really powerful. It lets us kind of create multiple instances of things and allows us to kind of continue this trend of reusing code and becoming more efficient with it. Let's take an example of the bouncing ball sketch that we've kind of been working with and think about what parts of that, if we were going to make an object out of it, would be considered data. I have a list of items right here: color, X location, Y location, the diameter or the size, speed as well. And then some of the functions that we might have for this, in the previous examples, we've used move, bounce, and display. If we were gonna think of another example or extend this thinking to something like people, like what if you had a person and you wanted to, build the structure around them, you might think for data, it could be their height, their weight, gender, eye color, handedness, all these different things are data, around the person. And some functions might be like eating, sleeping, walking, talking, jumping, all these things can be built up into or constructed and become part of the object. Let's think about in processing, the way we're going to create objects is by using a class or creating a class. And a class, one way to think about it is it's a template for objects. Sometimes thinking about it as like a cookie cutter could be helpful. I like to think of it kind of like you're building like an assembly line or kind of a factory, like a means of production, and you're just setting it up so that, because for me, the nice thing about creating a class is that you can create different types of, or you can create objects with different data, or you can they can be customized a little bit. So to me, it's almost like an assembly line where you can build similar but customizable things. The 4 elements of building a class, you need a name, and it's like a variable name. You can choose that. The data that goes into it, a constructor, which kind of is sort of like the setup or the initialization of it, and methods or functions. Sometimes you'll hear these used kind of interchangeably when we're talking about object-oriented programming, where I guess the technical term is methods, but they're essentially like functions within the object. So again, here are the 4 elements. This is a class for the bouncing ball on the right, and I want to just highlight all these different elements. You're going to start with, and again, this is the template that you're building. This is the sort of assembly line. You'll start with class. The name is ball in this case, and you have curly braces, and they're going to hold everything inside of it. So let's just be aware of that structure. Then you have the data here. So here are the variables that will be used in this case. And the constructor, again, is sort of like the initialization, or this kind of the setup. You're passing variables that you might receive when you initialize this object, and you're just kind of it's a little bit repetitive or tedious in that you're kind of creating temporary variables, and then you're kind of exchanging the data there. And then below that, we have the methods. And again, you can have a bunch of different methods or functions. Each one is its own code block with curly braces here. And each, you give it a name in this case. As far as using an object, here would be the code that would run. Would be the code in your main sketch. This assumes that we already have this class set up. In this case, we said the class was ball. Well, to start off with, you have to declare the object. Here, in this case, we're going to call it my ball. So declare object up there, and then you'll initialize the object. Here you have my ball equals new, and then ball, And inside of here, this is kind of like passing arguments into a function. These are the values that you're going to pass in and construct the object with. And then from there, you can call methods on the object or call the functions. We'll use the object name, in this case my ball, and we'll use a dot syntax. So we'll do dot and then the name of the function and parentheses in this case. This function, these methods here could also take arguments. They don't in this case because we've already set it up and written it a certain way, but again, these will behave like functions. So we're going to go over how to create this sketch using object-oriented programming. Let's begin. We're going to start off coding in here. We'll start it off like any other sketch, void setup, and a void draw. Now, the class that we're going to write, the ball class, that's going to go outside of draw. So we could start writing it here. And again, this is naming it, and we also want to make sure we open and close these parentheses, and everything is going to go inside of here. Let's first talk about the data that's going to go inside of here. We are going to just put the variables here that we want to use in the sketch. Color. Now, color is another type of variable which we haven't covered, but it's nice because it can hold the color value in a single value or in a single variable. We'll do a float just so that we have a little bit more flexibility in case the number is not an integer. Let's also get a float for diameter and a float for speed. So this is the data. The next thing we're going to do is work on creating the constructor, which I said again was passing sort of values into each other, passing variables, a temporary variable into another variable. What we need to do here is, again, like a function, we want to make sure that the type of variable and the number match up with what we're passing into it. So we're going to pass these values into it. So I need to make these temporary variables. So I'm just going to say temp C. And for me, having just a repeated structure that I use is helpful. Some people use an underscore or some other character, but I just want to probably get in the habit of doing the same thing so that I do it with fewer mistakes. That's just the way I approach it. So temp diameter, and I'm just doing it in camel case. So the first letter is lowercase, but then the second, I should say the second word, the first letter gets capitalized like this. Close, whoops, sorry about that. I might need to make my screen a little bit wider so you can see this. Okay, so we'll close that out. That is all in a parentheses after ball, and then we're gonna make inside of here 2 more curly braces. This is another code block, and inside of here we need to just pass the variables. So what we're doing is assigning the temporary variables to object variables here. So we received them in this form, and now we need to kind of make sure the values slot in correctly. So C is going to equal to temp C. Again, this is a little bit tedious, but once you set this up and start using multiple objects, it's going to be a lifesaver. And it's really going to let you do some cool things. Okay, so just want to make sure I've spelled everything correctly. I think I have. Then the next part here are going to be our methods or functions. So in this case, the functions are going to be of the type void. So we don't, void move. We don't want to return anything, but we're going to take the code that we've had before, which is y plus equals speed to move that ball up and down. And void bounce, if y is greater than the height, minus, I'm going to do a minus here so that it actually looks like it bounces when it hits the edge. So diameter divided by 2 is half of the size, so that's going to make it look like it's actually going to the very edge. Or using 2 vertical lines, y is less than diameter divided by 2. So instead of y is less than 0, we'll use diameter divided by 2. And then we'll just say speed times equals -1, or you could also say, this is the same as saying speed times -1. Okay, I'm moving to the next code block. Now be careful here. You want to make sure you jump all the way over. Sometimes hitting Command T just to clean it up. I'm outside of void bounce. This is a separate function or a method I'm writing display. Open it and close it. And from here we can give it a fill. Maybe we'll turn the stroke off because we don't really need it. And then we'll draw the ellipse here. X, Y, diameter. Okay, so we've written the class here. Just to clean this up a little bit, I could leave it here. I'm going to cut it, and I'm actually going to add it as a new tab on this side. I'll call it ball, right? So it matches up. And this is a way to organize your sketch. You could have many classes in here. You could have other functions written in here, but this allows us to kind of add new tabs, and they'll get saved as separate files inside of our folder. Okay, so let's just set up the sketch. I didn't do this all the way through, so we're going to set that up there. We'll make the background white. Okay, so I said we need to declare the object, and we'll call it my ball in this case. So declare the object, and we'll make a global variable here. I'm gonna set the color right now. I have a particular color in mind, and again, what I like about the variable color is it can hold the color value just in one variable. I don't need to do separate RGBs if I do in this form. I'm using hexadecimal color values using this number sign and then 6 values after. Okay, we'll go to my ball is equal to new. So we're kind of creating it here. So I'm initializing the object here, and I'm going to put in the values. C1 for color, 100 for X, 100 for Y, 25. So speed is going to be 5. Again, these need to match up. So 100, 100, 20, and then 5. That's what's being passed into it. Okay. And then from here, we want to call the function, because if I run this, you're going to see nothing because we're not displaying it, we're not moving it. It did get set up, but we need to run the functions on this. Move it, bounce it, if necessary, right? Those are the conditional statements that let it bounce, and display it so we can actually see what's happening here. And there we go. We've created a class, and we're using object-oriented programming. Again, we've created this template. The nice thing is, this template is set up. I could always change this to different values, and it'll behave differently, right? So it's like I said, I'm customizing the output. I could make this go twice as fast, right? And I could put this at, start this at a different location. Here it's at 20. So yeah, that's the power of this. And again, we're going to start off simple, and then we'll layer things up as we go. If we looked at the Y position of the bouncing ball, it would look something like this. This is sort of a linear graph, and you could see probably it goes up to a certain point, and then it changes direction, and it goes at a constant speed. That's why you're seeing it represented as straight lines here. Another type of movement we might see is something that's more wave-like or more sinusoidal. This is a sine wave And you can see here the graph kind of curves a little bit as it gets towards the extremes, and that's going to result in something that looks a little bit like deceleration into the highest or lowest point, and then accelerating out of that, and that's kind of a nice motion, something that we're more used to seeing. It's more natural. It feels a little bit more fluid. So in this example, we're going to use a sine wave here to drive the y location, the y position, and we're going to write this using a class. So we're going to, again, practice object-oriented programming. To start off with, I just want to actually write a little bit of code to show you how the sine function works. We're going to start the void setup, void draw. And we'll keep it, again, maybe 400 by 400. So if we looked at the graph again, you should be able to see that when we give it, let's say, an x value of 0, the output is going to be 0. But if we gave it a value of pi divided by 2, now that's in radians, that's also 90 degrees, then the value would be 1. And you can see that if you, at its lowest extreme, the value that's returned is -1. So a sine and cosine function, they always return values in between 1 and -1, depending on the value that we feed into it. Okay, so let me go back and show you kind of what I mean here. Now, whenever we use sine or cosine, we want to think of feeding it an angle value, just like we saw in the graph. The values, 0 all the way to 2 pi is 360 degrees, and we can feed it values like that. So I'm going to create a variable up here called theta. It's going to start off as 0, that's by default, and down here I'm going to say theta plus equals to 0.01, so a very small increment. Again, it wants to take values in radians. So up here I'm going to say maybe what I'll do is I'll use this as the y position of a circle or a ball here. So I'll do width divided by 2. I'm going to say height divided by 2. I want it to start in the center, plus sine of theta, and let's start with 20 and 20. So inside of here, let me also draw a background of a white background, and let's run that and see what happens. Now, you probably aren't really seeing much of a difference because this output is only going to be between -1 and 1, so it's quite small. So in order for us to see a difference, we have to multiply it by another number. In this case, let's try 100, and let's see what that looks like. So now it's going up by 100 and down by 100, and you can see that it's as it gets to the top, it kind of slows into that movement, and it slows down, and as it reverses direction, it starts to speed back up again. So that's a more wave natural motion. If I want this to go faster, all I have to do is increase the amount that I'm incrementing the theta, and there you go. You'll see a more springy motion, just a faster motion. Okay, so another way to think about this is that maybe I have an increment here, and I can, right now I'll call it 0.1, but what I want to do here, I'm just trying to show the basics of how this works and how I want to start to write this as an object. So this, hopefully you can see what we're going to do is take this and make it go all the way up and down. If we wanted that to happen, we could say times height divided by 2, and that should take us, there you go, all the way up and down, because again, the values that are returned from the sine function are between 1 and -1, so we got to multiply that, really amp it up, so we actually see a change. So if I was going to continue writing this using object-oriented programming, I want to create a class, and I'm going to do that up here, creating a new tab. I'm going to call this ball again, and I'm going to go through the steps of creating this class. First, we'll say class. We'll give it a name, ball. We'll put all of this inside of one large code block. We're going to declare the variables, and this might be repetitive, but I think it's helpful to see it again. We're going to feed color into it, an X position, a Y position. Let's also do a diameter, float speed. Now, we're probably changing things up a little bit here. I actually don't think that I need speed in this case. I'm going to comment it out, because instead of the thing that's going to be driving this is really the sign function. So we'll need theta and we'll need increment. Those are variables that we used in the other sketch. From here, we're going to use a constructor, and we're going to feed those values. Again, the constructor is really about assigning temporary variables to the object variables. So we need our temporary variables. I'm going to use temp C, float temp Y, float temp X, float temp. Again, super tedious, but it has to be done. And let's see, I also need, again, this is where I wish my screen were a little bit wider. So let's just pull that out. Float temp theta. And this is where people can always get tripped up. If you spell something incorrectly and they don't match up, that's going to be a problem. Now, in this line, we're going to just feed all the variables into each other. So, sorry, you're just going to have to watch this happen. And of course, I never type it super cleanly. All right, so that looks okay. I hope I spelled things correctly. Maybe I made a typo. We're gonna write a function here. I'm gonna simplify it a little bit. I know in the past we had display, bounce, move. I'm just gonna put everything into a run function. All right, so if you remember, we had that ellipse, and we started off with saying it's height divided by 2 plus sine of theta times height divided by 2. So I'm, reorganizing, refactoring some of the things that I did. I also said theta plus equals increment here. Let me grab that color value and throw it into here. I'm also going to style it with no stroke. And from here, then I can pass the X and the Y, because this Y, I updated the variable up here. I didn't write it in here, but I could have done that, but maybe it's a little bit cleaner now for you to see this. Okay, so that's me and the class. Let's hope everything is okay. Now I want to go back into my sketch, and I'm going to need to clean this up a little bit. This I've already kind of specified in the class. What I want to do now is declare the ball here. So I have my ball here. We have that orange color that we used in the past, which we said was FA8712. And here we're going to initialize the object. So new ball, we'll give it a color. Remember, it has to follow this structure. So let's see. Oh, did I put? I should be careful here. It looks like I swapped these out. I started with X and Y, and that's going to create an issue if I don't catch that. Okay, so we want to do the X and the Y here. Maybe we'll start with 100 for the X. Height divided by 2 is, again, the starting off point for the Y. Although I realized, you know, I've kind of overwritten that here, but it's okay. Let's go to 20, 0. For the theta is going to be 0 to start with, and then the increment 0.05. So not too big, not too small. So initialize the object here. From here, I don't need this stuff. All I need to do then is write my ball run, and I should get everything to work if I've created the template correctly. There we go. So that's all set up. And you know, I just realized, yeah, like I said, I think that this value is not really going to make a difference, since I am feeding this value in, I realize, but then I'm overwriting it here anyways. So I might not even need that, to be honest. And again, if I wanted to write it without it, I would take this out here, and then I'd also take this out so that the number and the type match up. Okay, so while we're here, let's practice having another instance of this, another object. So we're going to have my ball and my ball 2. We'll separate with a comma. So this is declaring these two objects, and now we want to set this up here. We can do the same color. Maybe we shift it over to the right. I mean, I put that in there. It might make a difference for another sketch. I'll just leave it like it is. 20. Let's start at a different angle. So instead of starting at 0, we'll start at pi, which should shift it a little bit over, and then we can start with the same increment. And again, nothing will show up unless I also run the function here, run, and let's take a look at that. Okay, so now we have these two balls. They're being controlled by the sine wave, like a more fluid motion. Again, making the class lets me create a template so I could change things up, make this go faster, and they're kind of independent. Now you can see that thing's going at its own crazy speed. So as we get into the next video, we'll look at how you could make many instances of these all at once, just simplify it. But this is a good foundation to build off of.